Bismillahir Rahim. So let us discuss conditional probability. So the conditional probability of event A, uh, given the occurrence of a related event B, is the the conditional probability of an event A given the occurrence of a related event, right? Related event B is given by this formula, probability of A given B, right? So B is an event which affects the outcome of event A, right? So probability of A given B is equal to the probability of A intersection B divided by the probability of B. So A intersect B can also be represented like this. So this is our conditional probability of A given B. So it can be seen that it exists only when probability of B is not equal to 0. So it is defined only when probability of B is not equal to 0, right? And that probability of B is and probability of B is greater than 0, right? So because probability cannot be a negative value, so it's always greater than 0, and it should not be equal to 0 here in this case. So when probability of B actually is equal to 0, then B does not occur. So we cannot say that A given B occurs. So when B is not occurring, we cannot say that. So it is not defined in that case, but the conditional probability is not defined in that case. So a conditional probability has the some properties related to the probabilities of the axioms of probability. So the conditional probability has the following properties corresponding to the axioms of three axioms of probability. So number one, probability of A given B is greater than or equal to 0, right? It cannot be negative. Number two, probability of B given B is equal to 1. This is quite obvious. So B has occurred, so it means that the event is the probability is 1, right? So it is a certain event, so we can derive this from here also. So probability of B given B is equal to probability of B intersection B divided by probability of B. So we know that the intersection of B and with B itself is B. So this is 1, right? And number 3 is if A is union of these events, A1 union A2 and so on, such that any two events, the intersection any two events is a null set, right, for all I is not equal to j, that is all these events are mutually exclusive, then probability of A given B is equal to probability of A1 given B plus probability of A2 given B and so on, right? So the only condition is that the all these sub events a1 a2 are mutually exclusive, or they are disjoint events, right? So they are disjoint events. In that case, this holds. So these are the three properties related to the conditional probability.